This is 4.2, part 2, and we're going to move on to example number 2, where it combines what we learned today with what we learned last day, and moving a little forward. We're going to use estimation skills to place all of 3 of these onto our number line, and then we're going to use that to list the numbers from least to greatest, which is smallest to biggest. So let's take a look at square root of 17 first. Square root of 17. Is that on my list from page 1? Look back to square roots. Is 17 on there? No. But I have 16 and 25, which means 17 would slide right in there somewhere. So let's approximate the square root of 17 by using the method we learned last day. The square root of 16 is going to be 4. And over here I'm going to have the square root of 25, which is going to be 5. And in between there, I'm going to draw 9 tick marks. And I want to keep in mind that this is $4 and this is $5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you know me, and my tick marks aren't exactly perfect, but that's okay. It's good enough. Each of these tick marks is a dime. So this is $4.10, $4.20, $4.30, $4.40, $4.50, $4.60, $4.70, $4.80, and $4.90 and $5. Where would the square root of 17 fit? Well, I need 16, then 17, 18, 19, 20, 21, 22, 23, 24, 25. Well, where's the square root of 17 going to be? Right next to him. Now the square root of 17, what do I think his estimate is? Well, I have him placed essentially right on the top of 410. So I'm going to say or assume that the square root of 17 is about 4.1. And I'm going to go over to my number line that was given, and I'm going to put the square root of 17 right here. Now the cube root of -8, I actually don't even need to use this method for it. The cube root of 8 is good. It's on my list. And cube roots can have negative numbers. So the cube root of 8 is not just 2, but -2. I'm going to jump right to putting that on my list. So here's -2, and right above that, I'm going to place the fact that that is the cube root of 8. Now, the cube root of 6, that's not on my list, so I'm going to have to repeat this process for that. Cube root of 6. Let's take a look. Here's my cube root. I have the cube root of 8. Now, what I added was, I don't know if you can see this clearly or not, but this says that 1 cubed is 1. So the numbers that work for cube roots are 1, 8, 27, 64, and the cube root of 6 is going to fall somewhere between 1 and 8. So those are the 2 terms I'm going to use for my number line type situation. So the cube root of 1 is going to be 1. And I'm going to go up by dimes. This is going to be $1.10, $1.20, $1.30, $1.40, $1.50, $1.60, $1.70, $1.80. If I do it this way, my number line works out better than the other method. $1.90 and $2. Well, who is $2? $2 is the cube root of 8. Now, where does the cube root of 6 fall in here? Well, I'd have the cube root of 1, cube root of 2, cube root of 3, cube root of 4, cube root of 5, cube root of 6, cube root of 7, cube root of 8. Where is the cube root of 6? Well, I'm going to put them right about there-ish. My estimate for the cube root of 6 is about $1.80 or 1.8. So over here, I'm going to say that the cube root of 6 is about 1.8. So going back up here, I'm going to put the cube root of 6 on my number line at 1.8. Now the question says, use this number line to list the numbers from least to greatest. And that's actually the answer that I'm looking for. So down here, I'm going to indicate that my list is from least to greatest. And my smallest is the cube root of -8, followed by the cube root of 6, followed by the cube root of 17. And right down here is the answer that the question is actually asking for. Last page. We have another question similar to the one we just did. Cube root of 18, cube root of -30, and cube root of 27. Well, the cube root of 18, or pardon me, square root of 18. Square root of 18 is not on my list, but the square root of 18 is somewhere between the square root of 16 and the square root of 25. So the square root of 16 is $4, $4.10, $4.20, $4.30, $4.40, $4.50, $4.60, $4.70, $4.80, $4.90, and $5, which belongs to the square root of 25. Now where do I think 18 falls in there? Well, I need 17, 18, 19, 20, blah, blah, blah. I'm going to put the square root of 18 right about here. So I'm going to estimate that the square root of 18 is about 4.2. Let's go up here. And right above 4.2, I'm going to put the square root of 18. Now, cube root of -30. It's not on my list, and negative cube roots are legal. So let's repeat the process for that question over here. What do we have? So the cube root of -30. We kind of pretend the negative isn't there for a minute. And which cube roots work? Well, 1 works, 8 works, 27 works, or 64 works. And the cube root of 30 is going to be right in here somewhere. So what we know right away is that the cube root of anything negative will be just a negative number. So I'm going to deal with that negative right now by putting that as part of my answer. But down here I'm just going to deal with the 30 as if it's positive. And I'm allowed to do that. So which cube root am I starting with? I'm starting with the cube root of 27. And the cube root of 27 is 3 exactly. Then we have 310, 320, 330, 340, 350, 360, 370, 380, 390, and $4. And $4 comes from the cube root of 64. Now, where do you think the cube root of 30 would lie in there? Well, we need 28, 29, 30, all the way up to 64, which is fairly hefty. So the cube root of 30 is going to be really close to this cube root of 27. And in fact, I'm going to put them right beside there. And I'm going to estimate that the cube root of 30 is about 3.1. Which means that the cube root of -30 is going to be about -3.1. So going up to my number line, -3.1 is right about there, the cube root of -30. And then the cube root of 27, well, that's perfectly on my list, and that is exactly 3, which goes right here. Again, I want my answers from least to greatest. Please make sure when you're doing these questions that you don't assume it's least to greatest, because occasionally you'll get asked greatest to least. So, least to greatest is the cube root of -30 followed by the cube root of 27, followed by the square root of 18. And again, that's the answer that they were looking for. The last question comes from inequalities. And you need to realize that there's 4 types of inequalities that can be written. And in general, if I give you this sign here, we're going to consider this to be the small end, and it's always going to point towards the smaller number. And this is the big end, and it's going to point towards the bigger number. So tell me, are these true or false? Well, the cube root of 8 is 2. Now the square root of 8 in this question here, let's figure out where the square root of 8 would be. The square root of 8 would be somewhere between the square root of 4 and the square root of 9. And after a while, you can kind of approximate a little bit for this, because here's 2, here's 3, 2.5, oops, 2.5 would be somewhere in the middle between 4 and 9, 5, 6, 7, 8, 9. So that's about this. The square root of 8 is going to be somewhere around here, and it's going to be like 2.7 or something. Now the exact value of that doesn't matter. Is this correct? Is this guy bigger than this guy? Because right now the big end of my sign is pointing towards him. Well, no, that's false. Because the cube root of 8 is in fact smaller than the square root of 8. 2 is a smaller number than 2.7. This one here, the 5th root of negative 32. A little bit hard to see. The 5th root of negative 32 is on my list. 5th root of 32 is 2 with a negative, and the square root of 16 is 4. Is this guy smaller or bigger than him? Is he colder or warmer? Well, he is definitely colder than 4 degrees. So the fact that the small end of this sign is pointing towards the negative 2 is good, which makes it true. And when it asks you to explain, I've explained by verbalizing it. For full marks on a question, you would need to explain in words, writing them down, the reason that this in fact is true, because negative 2 is a smaller number than 4. All right, your assignment for 4.2 is at the bottom. Again, no calculators are allowed unless it specifies you need to use a calculator, and you're going to use that table on page 1.